Hi everyone, in this video I'm going to be talking about coordinate systems. You might hear mention of the Cartesian plane, that's one example of a coordinate system, and this is part 1, part 2 will be in the next video. If you're going through the whole course, the coordinate system is related to our previous videos on elementary algebra, so recall our discussion around variables and the use of algebra to model the relationships between variables that we're interested in. What we're going to see in this video is that coordinate systems allow us to represent these algebraic relationships visually. So to help us along, let's first imagine a number line. So a line where different spots on that line represent different numbers. And we're going to go from low numbers to high numbers as we go from left to right. And this can be a very rudimentary way of visually representing what our variables are doing. So let's say I had 4 people and I measured their heights and I got these values back: 145, 90, 179 and 125. I could represent these values on our number line like this. I'll just put a dot at each height measure. So 145 for person 1, 90 for person 2, 179 for person 3, and 125 for person 4. So actually, if you have a look, this line gives us a pretty good way to represent some of what is going on with these values. For instance, I can see just by looking at the dots on the line that person 1 is lighter than person 3 but heavier than person 4. All right, well then let's imagine that I also measured each person's weight. So 50 for person 1, let's say, 30 for person 2, 75 for person 3, and 45 for person 4. Well, then I could put another line in and I could put points on that line that represent our individuals' weights as well. It would look something like this. So 50, 30, 75, and 45. Now, let's imagine that I put one of our number lines flat down like I have been doing, so we can make that height. And one line I'm going to flip up vertically like this. That will be weight. And the positioning of our number lines in this way allows us to define a new space. I'll put in a grid to show you. This is called a plane, and each point on that plane is associated with one height measure and one weight measure. So let's bring back our table and we can think about person 1. Their height was 145 and their weight was 50. So that point would be about here. And this one dot tells us 2 pieces of information. There is a person whose weight is 50 and height is 145. So by flipping one of our number lines up, we have created a plane where we can represent 2 pieces of information with one dot. All right, let's do person number 2 now. Their height was 90 and their weight was 30. So that point would be about here. For person number 3, their height was 179 and the weight was 75. So that's about here. And for person number 4, 125 was the height and the weight was 45. And what we've done here is that these dots are called coordinates, hence the name coordinate system. Now you might see our coordinates being labelled like this, with the height measure first and then the weight measure. And that's just convention. We always write the value of the variable that's on the horizontal axis or the horizontal number line first, and then the value of the variable that's on the vertical axis. And representations like this are really cool because it will allow us to see relationships between our variables, between, in this case, height and weight. For instance, we can see here, if we have a look at the points, we get this upward orientation like this. And this tells us in general that as we get taller, as height increases, our weight gets higher as well. So we would say here that there is a positive relationship between height and weight. And I should say, sorry about this diagram, it's not super to scale. There's better diagrams later. And just more generally, you might remember such systems from high school where we have, X usually on the horizontal and Y on the vertical. And when we have 2 variables like this, it's often called the Cartesian plane after René Descartes, who invented the coordinate system. And so just very abstractly, our lines are called axes. In the middle here where they meet, we have what we call the origin. And at this point, both of our variables are equal to 0. Now the upper right square that we see here, that's called the first quadrant. The lower right area, that's the second quadrant. The lower left is the third quadrant, and the upper left is the fourth quadrant. Now note that in the first quadrant, both x and y will be positive. For instance, at point A, which I've marked where x and y are both equal to 7. In the second quadrant, x is positive, but y will be negative. For instance, at point B that I've marked here, where x is equal to 2 and y is equal to -4. In the third quadrant, for instance, at point C, which I've marked there where x is equal to -9 and y is equal to -7, both x and y will be negative. And in the top left quadrant, that's the fourth quadrant, x will be negative, but y will be positive. So for instance, point D, x is -4, but y is 4. Now, two things are worth noting at this point. The first is that x and y could be any variables that we're interested in. So for instance, in economics, we could have axes that looked at the price and quantity, or quantity and total cost. We could look at gross domestic product and time. And the second thing that is worth noting, that very often in economics, we do work exclusively in the first quadrant, since many of our variables do not exist in the negative, or at least in any standard interpretation of what's going on. So for instance, we don't really think about negative prices or negative quantities. Now, when we read these diagrams, what sort of things should we be looking for? Well, it might seem obvious, but be aware of what is on your axes. To give you an example, I used to teach a course that taught PPFs, so Production Possibility Frontiers, in week 1 of the course. PPFs that tell us all about how much of two goods that an economy can produce, given their scarce resources. So here on this axis, I have good A and good B. And this point, for instance, would be interpreted, if we were at this point, we would be making 15 units of good A and 10 units of good B. And then in this course that I was teaching, we taught demand in week 2, which shows how quantity demanded changes as the price changes. So we had price and quantity on our axes. And so the point marked, for instance, would say that if the price is 4, then 900 units are demanded. But students would get mixed up all of the time between these two diagrams, these two very different concepts, because sometimes PPFs are straight, like I've drawn them here, and so they look kind of like, or they have the same shape as demand, but they're completely different things. Apart from knowing what's on your axes, as I gestured to before, the orientation of the points on our axes is also worth noting. So if we look at our demand schedule again, we see a negative relationship. As price increases, quantity demanded decreases. You can see it like this. For higher prices up here, those points are associated with lower quantities. If we look to where prices are relatively low, those points are associated with higher quantities. If we look at this second axis here, this axis tracks total cost over different quantities produced. And you can see that there is an upward orientation to our points, just like our height and weight example. So we have a positive relationship. And we can think about it like this. For smaller quantities, total cost is smaller. As quantities get larger, total cost is higher. And we can also, in this graph, see the orientation is kind of flatter and steeper in different parts. So we can look at that too. So initially, the rising total costs, we have kind of a flatter section. The rising total costs are less dramatic relative to up here, where total costs rise faster. It's steeper. So total costs do seem to rise faster for later quantities. Now, if we saw something like this, you can see that as our time periods increase, the quantity of lemons sold, that seems pretty constant. It changes a bit, but it's pretty constant. So we would say that there is no clear positive or negative relationship here. Quantity remains constant. Let's look at one more. Let's look at an axis which tracks GDP over time. And here there does seem to be more what we would call a cyclical pattern. GDP growth goes up between 2000 and 2003. Between 2003 and 2004, GDP is stable. It doesn't really change. And from 2004 to 2010, GDP growth decreases. In 2009, GDP growth was 0, didn't change. And in 2010, GDP growth was negative. It stays negative for 2010 and 2011. It goes constant for a while, and then we start increasing again. Now, one last thing to note for this video at least is that we've been working with 2-axis systems. So we have 2 variables. That would be a 2D system. We can think of 3-axis systems. They look like this. They involve 3 variables. That would be in 3D. So we would have one axis here, here, and here. If we're talking abstractly, we often use X, Y, and Z. So a point that I've marked here, for instance, that would be associated with 3 different variable measures. So it would be Z is equal to 6, Y is equal to 2, and X is equal to 1. Again, Z, Y, and X could be any variable. In economics, we often think about, good 1, good 2, and utility. We can struggle to imagine 4-axis systems and above, though that's really hard. We can't really imagine past 3 dimensions. So just to review, coordinate systems can give us a visual representation of the relationship between different variables. They consist of number lines or axes which define spaces where we can plot coordinates. It's important to know what the coordinates actually mean. You can check the orientation to see if there's any positive or negative relationships, and you can look to see how steep or flat the changes are. Lastly, we have 2D axes, but we can think about adding more variables, but really after 3 axes, it's a bit difficult to imagine. So that's it for this video though. It's pretty conceptual, this video. In the next video, I'm going to go through the next part of our introduction to coordinate systems. I'm going to be discussing the difference between continuous and discrete variables and using our axes to illustrate continuous functions. So when we have smooth lines. And I just realized there's a mistake in the heading. I don't think there's supposed to be a hyphen, or it's not the usual. I hope you guys forgive me. If you would like written notes to help you on your journey, or even just to support this channel to help me make more videos, you can visit my store. The notes include lots of practice questions with solutions, which can really help you solidify your understanding of the skills discussed in this video. If these videos have helped, please like and subscribe, comment below, share, all of that. It all helps. Any feedback is also welcome. Hope you guys are doing well.